Okay, this is pre-calculus video 2.5, solve higher level polynomial inequalities. And again, this is even a little bit rougher than the quadratic inequalities. And it's a lot like quadratic inequalities, but you just have to remember some things about graphing other polynomials. All right, again, I want to first start out by finding the roots. All right, so I'm going to factor this. It has a GCF of x. And inside the parentheses, I've got the difference of two squares. Set my factors equal to 0. And solve. Okay, so I've got 3 roots. Let me graph those 3 roots. Let me bring down my original problem to look at the graph. Okay, so I've got 0. Maybe I should make that red. 0. I've got 1 and negative 1. Okay, so the graph intersects, those 3 points. Okay, now, you might remember something about end behavior. This would be an increasing graph, and I would have the left end down, left end down, and the right end up. You might remember that about end behavior from Algebra 2. Feel free to use technology to help you out here. And I'm going to move this equation again so that I can see it while I've got the calculator up. So, turn my calculator on. All right. I am going to restart my calculator. Thank you for your patience. There we go. There it is. All right, y equals, and I'm going to put this polynomial into my calculator. I've got x to the power of 3 minus x. All right, I'm going to graph this on a standard viewing window. Okay, and let me zoom in so you can have a better look at what's happening next to negative 1 and positive 1. Zoom in. Oh, come on, calculator. Why aren't you giving me a hard time here? There we go. Are you zooming in? You didn't look like you zoomed in to me. Zoom in. There we go. That's better. Thank you for your patience. All right. Let's try and draw a rough sketch of that. Okay, there's no precision that's needed here. The only thing I really need to know is when are my y values above the x-axis and when are they below the x-axis. My inequality I'm trying to solve is saying I'm interested in the greater than, right here. So that's this. That's above the x-axis. That's greater than 0, and this. Okay, so what x values, and now I'm just going to highlight them on the x-axis, that's these x values and these x values, okay? So what x values give you y values that are greater than 0, and now I'm going to put that into interval notation. All right, I change my pen, okay? All right, so my first interval is going to be between, and this is a closed interval, between negative 1 and 0. It's a closed interval. And that designates that little hump, okay? The other interval, and this is or because a number cannot be both, is going to be to the right of positive 1. And infinity always gets the round bracket. All right, I'm going to try another problem. All right, GCF first. Let's take an x out. I hope this is factorable. Are there factors of -3 whose sum is -2? -3 and positive 1. Delightful. Set your factors equal to 0 and solve. Okay. Let's pull this down here. Let's graph the Cartesian coordinate plane. Okay, -1, 0, and positive 3. -1, put that in red. 0, and positive 3. Okay, this again has the same shape as the previous graph, but again, feel free to use your calculator to help you analyze what they look like. So I've got x cubed minus 2x squared minus 3x. All right. I know that this is not the full graph. Let me put this on a standard viewing window and see if I get a better picture here. There we go. That's better. And I knew that because I knew something about end behavior. Again, this is a cubic. I've got to get the squiggle. I can't just get a parabola. All right. Let me try and graph that. Let me look at it again. Okay, got it. It doesn't have to be precise at all. All I really need to know is what parts are above 0 and what parts are below 0. Here I'm looking for all the parts below 0. So that would be everything to the left of -1 and everything between 0 and 3. So the x's would be there and here. Okay, we're going to put that in interval notation. This one is an open interval because there's no line underneath the inequality. So I've got between negative infinity and -1, or between 0 and positive 3. That's my final solution, and that's it for this video.